Objective question 44 for SHS candidates. The bearing of E from F is 20 degrees. So the bearing of E from F. Let's do it. It's 20 degrees. So 20 degrees will be somewhere here. And that of J from E is 140 degrees. So this is our F. And E will come here. So that of J from E is 140 degrees. So if this quadrant is 90 degrees, let's subtract. We are dealing with a bearing of 140. So 140 minus 90 is giving us 50 degrees. So it means we have to add 50 degrees to 8. And this will be 45. So 50 degrees will come here. All right. We have this to be 50 degrees. So it continues. If J is directly east of F, if J, which will come here, is directly east of F, so this is F. The east of F is this one. All right. So J is directly east of F. Let us join this. Okay, the question continues. Find angle FGE. The angle FGE. So this is the angle we want to find. When we look at this 50 degrees, it is alternate to this angle. So if this is 50 degrees, this is also 50 degrees. So therefore, our angle EFGE will be equal to 50 degrees. Objective question 27 for private candidates. Wassce is on a bearing of 27 degrees from Obin. So this is the position. So this is Obin's position, and Wassce is on a bearing of 27 degrees. From Obin. Wassce will be here. Let's continue with the question. And Sapon is on a bearing of 137 degrees from Wassce. So Sapon is on a bearing of 137 degrees from Wassce. So let's construct our plane here. So 137 degrees, 137. This 190. So let's see. 137 minus 90. 47. So we have to add 47 to that. And 47 will be around this place. Okay. Then the question continues. So Obin, Wassce, and Sapon will be around this place. If Obin is at a point equidistant from the positions of Wassce and Sapon, if Obin is at a point equidistant from the positions of Wassce and Sapon, so Obin is a point equidistant from the positions of Wassce and that of Sapon. Sapon will be around this place. So what that means is that when we join these two, the two distances, that's OB and OS, are supposed to be the same. All right. And the question continues. What is the bearing of obeying from Sapon? So the bearing of obeying from Sapon, that one will be from this place up to this place. All right. Here we saw that we added 47 degrees to the angle. That's 47 over there. So if here is 47, what will be the angle here? So that one, you subtract 47 from 90, and it will give you 43 degrees. So that one is 43 degrees plus. Now let's see. This angle, 27 degrees, is alternate to this angle. They are alternate angles. 27 degrees, and here as well 27 degrees. So that 43 degrees plus 27 degrees, so plus 27, is giving us a value of 70. So the whole of this angle is 70 degrees. Now we know that our OB line, OB, is the same as line OS because they are equidistant. Now we know that we can say that the angle 70 degrees is the same as the angle we have here. But with this, we can find this small angle here. This gives us the Z shape, that's the Z shape. If here is 47 degrees, likewise, this angle is 47 as well. So if you want to find the bearing of obeying from Sapon, it means we have to find this angle here, and we can represent that one with theta. All right. So since the triangle we have is an isosceles triangle, we can say that theta plus 47 degrees is equal to 70 degrees. Why? Because these two angles, the base angles here, are equal for isosceles triangles. So to find theta, theta will be equal to 70 degrees minus 47 degrees. So when we subtract 47 from 70, we are getting a value of 23 degrees. That's for theta. So to get the bearing, we have to subtract theta from 270 degrees because the bearing is from the North Pole to this line. But we know that from the North Pole to the west is 270 degrees. So we have to subtract theta from it. So therefore, the bearing of being from Sapon is equal to 270 degrees minus 23 degrees. So 270 minus answer, we have 247 degrees as our answer. Theory question 15B for SHS candidates. A cyclist starts from a point X and rides 3 kilometers due west to a point Y. A cyclist starts from a point X and rides 3 kilometers due west to a point Y. At Y, he changes direction and writes 5 kilometers northeast to a point Z. So let's begin with our diagram. So this will be the starting point of the cyclist here. Let's have our poles. All right. So as the question began, a cyclist starts from a point X and rides 3 kilometers due west to point Y. So this is the west side. Let me add a little. Three kilometers due west to a point Y. So this is our Y. At Y, he changes direction and rides 5 kilometers northwest. So this is our north pole and this is the west. So northwest is the middle of this one. And that one, he is traveling 5 kilometers. 5 kilometers. All right. And we are being asked, how far is he from the starting point correct to the nearest kilometer? How far is he from the starting point correct to the nearest kilometer? So this is our point XY. So here will be Z. So as the question is asking, we have to join this to get a distance, XZ. Alright, and there I find the bearing of Z from X. The bearing of this Z from X. So we'll do so when we get there. So the II part, to calculate, let's say for northwest, if there is a movement in the direction northwest, it means our angle 90 degrees will be divided into 2 equal halves. So this angle is 45 there. This small angle here is 45. So let's write that one, 45. Then this angle is also 90 degrees. So 45 degrees plus 90 degrees, we are getting a total angle of 135 degrees. So we have this angle. We want to find this XZ, and again we have XY and also have YZ. So if you want to find XZ, what will help us is to use the cosine rule. So we say that by the cosine rule, the length XZ square is equal to the length XY, which is 3, then you square it, plus the length YZ, which is 5. So 5 square minus 2 multiplying the lengths, that's 3, 5, cos the angle opposite to the line XZ, which is 135 degrees. So with the help of our calculator, 3 square plus 5 square is 34. Then negative 2 times 3 times 5 times cos 135 is giving us 15 root 2. Right? So to find XZ, we have to take the square root of 34 plus 15 root 2, and the value for our xz will be equal to, so square root of answer is 4. Let me come 34 plus 15. So 34 plus 15 root 2. Yeah, so square root of answer will give us 7 point, not 4. So 7.43 kilometers. But we are asked to leave our answer to the nearest kilometer. So therefore, the bearing, is it now the distance? Therefore, the distance from the starting point to his current position is 7 kilometers. That's to the nearest kilometer. For II, we have to find the bearing of z from x. So bearing of z from x. That means we start from the north, move clockwise to this line. So that's the bearing of z from x. But we have to find this angle. Let's represent the angle with theta. So we have theta as the angle we want to find. We have the opposite side. We know this angle, and we also know the opposite side. So we can use the sine rule. You can say by the sine rule, sine theta divided by the opposite side, which is 5, is equal to sine this angle, which is 135 degrees, divided by its opposite side, and it is 7.43 kilometers. So 7.43. So our sine theta is equal to 5 sine 135 degrees divided by 7.43. So 5 sine 135 divided by 7.43, which is the answer, is giving us 0.4758. So to find theta is the sine inverse of 0.4758. So the sine inverse of that will give us 28.41 degrees. But we are finding the bearing, and we know that from the North Pole to the West Pole is 270 degrees. So we have to add theta, which is 28.41 degrees, to 270 degrees to get the bearing. So we say that therefore the bearing of z from x is equal to 270 degrees plus 28.41 degrees. So plus 270. We are getting 298 degrees as the value for the bearing. Theory question 4b for private candidates. A ship leaves a port X and sails 30 kilometers due south. 30 kilometers due south. So we have a port X here. So this is our port X. So the ship leaves a port X and sails 30 kilometers due south. So these are 30 kilometers. And it continues. It then sails 60 kilometers due west to another port Y. So 60 kilometers. Due west to another port Y. Then it continues. Calculate correct to the nearest degree the bearing of X from Y. So this is our Y. Let me construct another plane here. Let me increase this a little bit. All right, so back to the question we're talking about. It says the bearing of X from Y. The bearing of X from Y. So this is the bearing. The bearing of X from Y. The angle we have here is 90 degrees. Simple. To get the bearing, you have to find this angle over here. So we can represent it with theta. And when you look at this, we have the opposite side with theta as 30 and the adjacent side as 60 degrees. So the trig ratio that we can use is tan. So we can say that tan theta is equal to the opposite side is 30 divided by the adjacent side, which is 60. So our theta will be equal to tan inverse of 30 out of 60. And finally, the value for theta is 26.565 degrees. But if we want to find the bearing, we have to subtract theta from the angle we have here, the right angle there, which is 90 degrees. So we conclude that therefore the bearing of X from Y will be equal to 90 degrees minus theta, which is 26.565 565 degrees. So 90 minus answer is giving us 63.43 and so forth. But we were to leave our answer to the nearest degree. So 63 degrees. But for bearing, so if we have 2 digits, you have to begin with 0. So 063 degrees to the nearest degree. Theory question 15 for private candidates. A boat sails 6 kilometers on a bearing of 037 degrees. A boat sails 6 kilometers on a bearing of 37 degrees. So this will be the starting point. It's sailing on a bearing of 37 degrees. So our 37 will be somewhere here. .37 and then 7 kilometers on a bearing of 68 degrees. So this one is 6 kilometers. So when it gets here, it sails a bearing of 7 kilometers on a bearing of 68 degrees. So 68 will be somewhere here. .68 degrees. And the distance, this 6 kilometers, 7 kilometers. Let me increase it a little bit. All right. So this is 7 kilometers. And we are asked, calculate the distance of the boat from the starting point. The distance of the boat from the starting point. So let's construct another one here. Then I think we can get our horizontal one as this. Then the distance we want to find, you join them together, the 2 points. All right. And the B part, the bearing of the boat from its starting point. Correct to the nearest degree. The bearing of the boat from its starting point. So there's from its starting point. So this is the bearing we are talking about. From this place to that place. That's the starting point. So the bearing of the boat, the final position from its starting point. That's where we read the bearing. But first of all, let's tackle the A. The A is saying that we should find the distance of the boat from the starting point. So this one, let's label here A, B, and this place C. Now, with this, we know that this angle is 37 degrees. So 37, we have the Z shape here. Z shape over here. So it means this angle is also 37 degrees. Let me write it here. 37 degrees, then plus. Then this angle is right angle, so it's 90 degrees. All right. Then when we come here, we have the total angle here to be right angle, which is 90 degrees. And we already have one at 68. So when we subtract 68 from 90, we we are going to get 22. So this small angle here is 22 degrees. So plus 22 degrees. So when we add the 3, 37 plus 90 plus 22 is giving us 149. So the whole of the angle here is 149 degrees. All right. This will help us to find AB. So by the cosine rule, our AB square will be equal to the length AC, which is 6 square it, plus the length BC, which is 7 square, minus 2 multiplying 6 multiplying 7 cos the angle opposite to AB, which is 149 degrees. So 6 square plus 7 square is giving us 85. Then negative 2 times 6 times 7 times cos 149 is given plus 72.00. Let me add 0.002. So the result we had plus 85 is 157.002. So to find AB, we have to take the square root of 157.002, and that one will give us 12.53. We are working in kilometers, but in the question we were to correct our answer to 2 decimal places. So therefore the question was about the distance of the boat from the starting point. So therefore, the distance of the boat from the starting point is 12.53 kilometers. We're doing the conversion to 2 decimal places. So for the B part, the bearing of the boat from its starting point, correct to the nearest degree. So the bearing of the boat here from its starting point, that's the angle we have from the North Pole to where the arrow ends. We have to find the angle inside the triangle. Since we don't know, we can represent it as angle theta. So we have angle theta. We know the opposite side to it as 7. Then we have angle 149 degrees. Opposite side to it is AB, which has a value of 12.53 kilometers. So we can use the sine rule. We are working on the B part of the question. So B, we say that by the sine rule, the sine of angle theta divided by the side opposite to it is 7. So 7 is equal to sine angle 149 degrees divided by the side opposite to it is AB, and it has a value of 12.53. So 12.53. So our sine theta will be equal to 7 sine 149 degrees divided by 12.53. So with the help of our calculator, 7 sine 149 divided by 12.53 is already in the memory. 0.2877. 0.2877. So to get theta, we have to find the sine inverse of 0.2877. So sine inverse of answer is given as 16.72 degrees. But we are talking of bearing. So it means we have to add the 16.72 degrees to the 37 degrees to get our bearing. So we conclude that, therefore, the bearing of the boat from the starting point is equal to, let's see the angle, this angle 37 degrees. The angle is 37 degrees, then plus theta, and our theta is 16.72 degrees. So when we add them plus 37, we are getting 53.722, but we have to do our conversion to the nearest degree. So that one will be 50. We run the 7 and add it to 3, so 54 degrees. But since we are dealing with bearing, we have to bring 0 in front for us to get the 3 digits. So 054 degrees to the nearest degree